Okay, so here we're given a multivariable function, fxy equals 3x cubed minus 2x squared y squared, and we want to find the sum of fxx and fyy. So first, I'll find the first partial on f with respect to x. And if I take the partial with respect to x, both terms contain an x. So if I take the partial on the x cubed, I get a 3x squared. All right, and 3 by 3 gives me a 9x squared. Minus 2 by 2 is a 4x y squared. So I just took the partial respect to x, which takes our value of y and sits on a fixed or constant value of y as I only look at variation along x. Given that fx, I'll take the x partial of it. And if I take the x partial of the fx function, I get fxx, which will give me 9 times 2, or 18x, minus 4y squared. So again, I just had an x to the first in this term in this function, and so that just gave me a 4 times y squared. All right, so let's find fy. And if I take the partial with respect to y, you see the first term is just going to be 0. And if I take the partial of the minus 2x squared y squared, I get a minus 2 times 2, which becomes a minus 4x squared y. Y goes to the first power. And so my fyy simply becomes the yth partial of fy, which becomes a minus 4x squared. And now if I join these terms together, my fxx plus fyy, which is also called, let's say, the Laplacian of f, which is just a term I'm throwing out there. But if I just gather my terms together, fxx and fyy, I get 18x minus 4y squared minus 4x squared. And now we have a new function, gxy equals x plus y ln y, and we want to find gx, gy, and gyx. So first, I'll rewrite my gxy function by distributing the ln y inside that binomial, and I'll get x ln y plus y ln y. And now I'll begin taking partials. If I take the x partial, gx, well, only the first term contains an x. So, and this is x to the first power, which is giving me 1 times the natural log of y. All right, so that was simple enough. Next, I'll find the yth partial. And by finding the yth partial, I notice that both terms have a y in it. So the derivative of the natural log of y will just give me the 1 over y times the derivative of y with respect to y, which is 1. So this gives me x over y plus, see, now I have a product rule because I have a function in y times another arbitrary function in y. So the derivative of y, or the derivative of the first, times the second, which is 1 times ln y, plus the derivative of the second, which is 1 over y times the first. 1 over y times y, which is just 1. Finally, I need to find gyx, which is basically the same as gxy for mixed partials. And you can see it's a lot easier to find gxy than it will be to find, say, gyx. So what I'll do is I'll just take the yth partial of gx, because my gx term is actually pretty simple. And if I take the yth partial of it, I just get 1 over y. Thank you.